All right, let's unpack this. In today's frenetic tech world, we constantly hear about DevOps, right? This sort of magic potion for faster software delivery. But then this other term emerged, one that adds a really crucial layer, Devsecops. It's far more than just a convenient buzzword. It represents a fundamental rethinking of how we not only build, but also, crucially, how we protect software while it's in motion. So today, we're taking a bit of a unique path on this deep dive. Instead of just, reviewing documents, we're going to use the very questions that define expertise in this field, almost like we're simulating a conversation with the sharpest minds in DevSecOps, all designed to really extract maximum actionable insight for you.
Yeah, and what's truly illuminating here, I think, is that these aren't just theoretical questions for, like, a certification exam or job interview. Not at all. These are the core challenges, the strategic crossroads, and the daily considerations that anyone working in, or even just with modern software delivery faces. They offer an incredible shortcut, really, to understanding the true depth of DevSecOps. They kind of lay bare the practical application of its principles in a way that, well, dry definitions simply can't.
Exactly. So the roadmap for our discussion today comes from some pretty insightful sources. We've got excerpts from a DevSecOps interview preparation guide, and perhaps even more illuminating, the book DevSecOps, Integrating Security Across the Development Lifecycle. And like you said, these sources don't just give us answers, they give us the right questions. And our mission for you, the listener, is to transform these crucial questions into a comprehensive, almost intuitive understanding of DevSecOps. We'll explore the implications, the cutting-edge best practices, and the very real challenges embedded in each query, offering you the kind of insights you'd normally gain from years of hands-on experience, but, without all the heavy lifting. So where do we even begin when we talk about weaving security throughout the entire development process? It sounds like a huge undertaking, a massive shift, right?
Yeah.
And it often starts right at the beating heart of how software gets built and delivered, the continuous integration and continuous delivery, or CI/CD pipeline. Let's kick things off with a couple of foundational questions that really set the stage here. Can you explain how you've integrated security practices into a CI/CD pipeline for a mid to large scale project? And maybe following that, can you walk us through your process for implementing automated security scans in a CI/CD pipeline?
Right. Well, when we zoom out for a moment, these questions immediately highlight a strategic imperative that's frankly often overlooked. Security must not be an afterthought. It just can't wait till the end. Integrating it into CI/CD isn't just about bolting on a few tools right before release. It's about a fundamental shift in workflow and, critically, in mindset. The game changer here, the truly surprising insight for many, isn't just that security should be continuous. It's that every single security check you embed earlier in the pipeline doesn't just catch bugs, it actually compounds your overall security posture. It's like a multiplier effect, turning early detection into a massive competitive advantage, not just some defensive cost you have to bear.
So if I'm getting this right, we're moving away from that one big monolithic security gate right before release towards maybe a series of smaller continuous gates. That sounds like potentially more checks, though.
Precisely. But think of it as gating security checks, but with a twist. It's not about adding friction, it's about adding intelligent, automated checkpoints. So this means that at the very initial stage, maybe at commit time, developers' code might go through pre-commit hooks. These hooks can run quick static analysis, SAS checks they call them, for common, easily identifiable issues, or even just enforce coding standards that directly impact security. Pretty neat, huh? Then as the code is committed, more comprehensive automated SAS tools run as part of the main build pipeline. These analyze the source code for vulnerabilities without actually executing it. This can proactively catch common issues like SQL injection, cross-site scripting, or insecure direct object references before they even make it into a deployable artifact. We also integrate software composition analysis, or SCA tools, usually during the dependency resolution phase. This is absolutely crucial because, let's face it, modern applications rely so heavily on open source libraries and third-party components. SCA scans these dependencies for known vulnerabilities, checks their licenses, flags potential risks.
The power here is immense. If a critical vulnerability is found in a library, think log4j, the build can be automatically flagged or even failed right there. This prevents vulnerable code from ever progressing. It stops a potential disaster before it even has a chance to leave the development environment.
Okay, yeah, I completely agree that catching those known library vulnerabilities early is a huge win, definitely. But a common concern I hear from developers is just the sheer volume of alerts some of these tools can produce. It can feel like noise. How do teams manage that effectively? How do they ensure they're focused on the truly critical issues without, losing that speed advantage they're trying to gain?
That's a really astute observation, and it's a very real challenge, no doubt about it. The answer lies in, well, intelligent filtering and prioritization. Firstly, you integrate the tools directly into the developer's workflow. So the feedback is immediate and actionable, not some giant report dumped on them weeks later. Secondly, you configure the tools. You tune them to focus on high-confidence, critical findings first. And you integrate them with developer tooling like IDEs so the warnings pop up right where the code is being written. Context is key. Thirdly, you can leverage security automation platforms or orchestrators. These can correlate findings, deduplicate alerts, and even apply contextual filters based on, say, the application's criticality or the type of data it handles. The goal isn't zero findings, that's often unrealistic. It's about surfacing the most important ones at the right time for the right person, allowing them to address them efficiently.
Right, makes sense. Prioritization. So once we've built and compiled and handled those dependency issues with SCA, how do we then test the live application, for those trickier runtime vulnerabilities?
Good question. After a successful build, and often in the testing or staging environments, we introduced Dynamic Application Security Testing, or DAST. This directly addresses another key question from our sources. What is your experience with Dynamic Application Security Testing, DAST, and how does it fit into a DevSecOps strategy? DAST tools test the running application, basically mimicking an attacker's behavior from the outside. They look for vulnerabilities that might only manifest at runtime, things like misconfigurations or authentication flaws that you'd only see when the system is operational, or even complex business logic flaws. DAST provides that external sort of black box view, which really complements the internal white box SaaS analysis we did earlier. It's kind of like having an ethical hacker continuously poking at your running application, finding things SaaS might miss.
Okay, so DAST is crucial for that live testing perspective. But let's face the uncomfortable truth here. Even with all this shifting left and rigorous testing, some vulnerabilities will inevitably slip into production. It's just the reality of complex software, isn't it? So when that happens, when maybe the worst case scenario materializes, what is the DevSecOps mindset? Is it about blame? Or is it more like a well-oiled machine for rapid recovery and learning? And how do you ensure the fix isn't just a band-aid? This brings us squarely to, how do you handle vulnerabilities discovered in production environments within a DevSecOps framework?
You hit on a really crucial point there. Production vulnerabilities are not a sign of failure, not inherently. They're an expected part of the continuous security lifecycle. The DevSecOps framework completely rejects blame. Instead, it emphasizes rapid detection, swift triage, agile patching, and then most importantly, profound learning from the incident. This requires robust monitoring, which I know we'll get into more deeply later, but also a seamless automated feedback loop. So when a vulnerability is found in production, the process should be detect it, alert the right teams instantly, triage its severity and exploitability, patch it with urgency, and then integrate the learnings back into the CI/CD pipeline. That last part is key. This means a thorough analysis of why it wasn't caught earlier. Was there a gap in testing? Was a tool misconfigured? And then you implement new tests or harden existing ones or maybe update secure coding guidelines to prevent similar issues in the future. It's about fixing the hole, absolutely, but also understanding how the hole formed in the first place and reinforcing the entire structure so it doesn't happen again.
And how do organizations balance that critical need for speed in patching with, well, the thoroughness needed for something like DAST? Especially since, as you mentioned, DAST can often be slower than SAST. It feels like a constant tension.
It is a tension, yeah, but it's a manageable one, usually through smart automation and strategic deployment. You're right, DAST can be more time-consuming because it interacts with the live application. It needs more resources, more time for a full scan. Balancing speed with DAST thoroughness often involves intelligent scheduling. Maybe run comprehensive DAST scans nightly or weekly in staging environments, while critical, high-impact features get immediate, targeted scans post-deployment. Some teams also use DAST in dedicated pre-production environments where they can run a full suite of tests without impacting any live users. Another approach that's becoming more common is using DAST alongside runtime application self-protection, or SSP. SSP can provide a layer of active protection in production by detecting and blocking attacks in real time, even if a vulnerability exists. It sort of buys you precious time to properly patch the underlying issue without immediate catastrophic impact. But the core principle remains automation. Automating DAST scan triggering, automated report parsing, integrating results directly into developer workflows. This ensures that even if a scan takes longer, developers get actionable results quickly, minimizing any latency in that crucial feedback loop.
We often hear this phrase, shift left, in DevSecOps, and it's almost become a mantra. hasn't it? It sounds like moving something earlier, which makes intuitive sense. But what does it truly entail for security beyond just, plugging tools into the CI/CD pipeline? It implies a pretty radical move from late-stage reaction to proactive prevention, doesn't it?
Indeed, it's about a profound cultural and operational pivot, really. Shift left means integrating security activities from the absolute earliest stages, think design and development, not just tacking it on at the tail end as a quality gate, or even just within the automated pipeline itself. And this raises a crucial question that, frankly, often goes unasked. How do you make security an intrinsic part of the entire development process, woven into the fabric of daily work rather than a separate gate or a specialized function that only security teams handle? It's fundamentally about empowering everyone, every developer, every product owner, every architect, to be a security advocate from the very first thought about a new feature.
So it's embedding security thinking not just into the code, but into the initial thought processes and design choices themselves.
Interesting. What strategies have you seen that are truly effective for shifting security left in the software development lifecycle? And maybe related to that, what's your process for conducting security code reviews in a DevSecOps environment? That seems like a key part of it.
Absolutely. One of the most impactful strategies for truly shifting left is proactive threat modeling. This happens even before a single line of code is written, right during the design and architecture phase. Seriously, before coding. It involves systematically identifying potential threats, vulnerabilities, and attack vectors for a new feature or application. By having the team collectively think like an attacker right up front, you can design security controls directly into the architecture and requirements, rather than trying to bolt them on later as an afterthought. This often involves structured methodologies like STRIDE, that stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege, or maybe DREAD, which is a model for risk assessment, to systematically assess and mitigate risks from the outset. Beyond just the design phase, a significant focus has to be on developer education and fostering secure coding practices. It's simply not enough to tell developers, hey, write secure code. We have to teach them how to do it effectively and efficiently. And this leads directly into the importance of security code reviews you asked about. In a mature DevSecOps environment, these aren't just formal audits performed by a separate security team that feels like a bottleneck. No. They're often peer code reviews, where developers are trained and empowered to look for security anti-patterns right alongside functional correctness checks. And automated SaaS tools integrated directly into integrated development environments, IDEs, or as pre-commit hooks, are also incredibly powerful here. Imagine, instead of finding a SQL injection vulnerability months later in production, a developer identifies it instantly while writing the code, prompted by an IDE plugin that highlights potential issues immediately. That immediate contextual feedback loop is absolutely critical for learning and prevention. It changes the game.
Yeah, that's a profound shift, isn't it? Moving from being told you did something wrong weeks later to being guided in real time. It sounds like a really natural extension of continuous improvement. So what does this all mean for the developers themselves? Are they just handed a list of new rules to follow, or do they truly become security champions in this model? These questions seem to hit this directly. How have you implemented security training or upskilling for developers in a DevSecOps team, and how do you address technical debt while maintaining security in a DevSecOps workflow? That technical debt one is tricky.
They absolutely become security champions, or at least that's the goal. The journey isn't about just handing them a rulebook and expecting compliance. That rarely works well. It's about cultivating a deep culture of security awareness, ownership, and capability. This involves continuous, iterative training, not just a one-time annual workshop that everyone forgets. Think practical, hands-on labs where developers learn to identify, exploit, and then fix vulnerabilities in a safe environment. Make it tangible. Gamification can be fantastic too. Making learning engaging and competitive fosters a desire to learn more, and establishing dedicated security champions within development teams is also highly effective. These individuals act as vital liaisons, bringing security concerns from their teams to the central security function and disseminating best practices, new tools, and critical info back to their peers. The overarching goal is to make security knowledge accessible, practical, and directly relevant to their daily coding tasks. Frame it not as an extra burden, but as an integral component of high-quality, reliable, and ultimately faster to deliver code. Regarding security technical debt, that's a constant pervasive challenge in any development cycle, and security debt is a particularly critical part of it. A mature DevSecOps workflow acknowledges that, realistically, not all vulnerabilities can be fixed immediately, especially in large, complex legacy systems or under extremely tight deadlines. The effective approach is to systematically track, prioritize, and address security debt. This means categorizing vulnerabilities not just by their technical severity, but by their exploitability and, crucially, their alignment with real business risk. What could actually happen? High-risk vulnerabilities that expose critical data or functionality must be escalated immediately, obviously. It also involves linking these findings to the product's backlog, making them visible and prioritized alongside new features. Transparency is key. The balance here is between maintaining velocity for new features and diligently addressing known risks. It often involves collaborative negotiation with product owners to dedicate a certain percentage of sprint capacity specifically to security fixes, much like how teams allocate time for bug fixes or architectural refactoring. The ultimate objective isn't zero debt, that's often an unrealistic fantasy, but rather debt that is well managed, transparently communicated, and continuously reduced over time.
This brings up a fascinating dilemma, though. How can companies truly incentivize developers to prioritize security fixes alongside new feature development, especially when, let's be honest, shipping new features often brings more immediate, visible business value and recognition? It's a classic trade-off, isn't it?
That's a sharp observation, yeah. And it often boils down to how security is integrated into core development metrics, into recognition programs, and into the very definition of done. First, security vulnerabilities, especially critical ones, should be treated with the same urgency as critical production bugs. That means clear service level agreements, or SLAs, for their resolution. If a critical vulnerability is found, it automatically gets higher priority in the backlog, perhaps even blocking releases until it's addressed. Make it non-negotiable. Second, recognizing and rewarding developers who consistently produce secure code or take the initiative to fix a significant number of vulnerabilities can create powerful positive reinforcement. Think internal awards, public shoutouts, or even incorporating security posture and contributions into performance reviews. Third, making security visible and even gamified, maybe a team dashboard showing vulnerabilities fixed over time, or security test coverage metrics can foster healthy competition and a greater sense of shared responsibility. Ultimately, it's about making security an undeniable part of done, in their definition of done.
If a feature isn't secure, it's not truly complete, regardless of its functionality. It's like building a house, right? You want to build it fast. But if you don't pour a solid foundation or check the electrical wiring, you're not saving time. You're just building in future disasters. Sometimes the fastest way to really deliver value is to slow down for a critical security fix, because a breach will always be slower, costlier, and far more disruptive in the long run.
Okay, we've mapped out the philosophy, the why and when of DevSecOps, integrating security early, shifting left, empowering developers. Great concepts. But as they say, ideas are cheap, execution is everything. So how do we actually do this? What's in the DevSecOps arsenal, the toolkit? Let's equip ourselves with the essential tools and techniques that turn these powerful concepts into tangible, secure software. Our sources bring up some critical ones right away.
Indeed. The DevSecOps toolkit is vast and constantly evolving, but some fundamental categories are pretty much non-negotiable for effective and scalable integration. It's really about having the right tool for the right job at the right stage in the process.
Let's start with static and software composition analysis. We briefly touched on these, ASTEST and SCA, but let's dive a bit deeper. What tools have you used for static application security testing, SS, and how did you integrate them into a DevSecOps workflow? And closely related, can you share an example of how you've used software composition analysis, SEO, to manage open source vulnerabilities?
All right, so SAST, as we discussed, is essentially that white box testing method. It analyzes an application source code or bytecode or even compiled binary code for security vulnerabilities without actually executing the program. It identifies issues based on coding patterns known to lead to common vulnerabilities, particularly those highlighted in things like the OWASP Top 10, think injection flaws, insecure deserialization, security misconfigurations, that sort of thing. Common enterprise-grade tools in this space, you might hear names like SonarKey, Checkmarx, Fortify, Veracode. There are others too, including open source options. The integration into a DevSecOps workflow is critical and happens at various points. Maybe as immediate feedback mechanisms via plugins in a developer's IDE, which is great for that instant feedback, or as a mandatory step within the continuous integration build process, so every code change automatically triggers a scan. Or even as gate checks that must pass before code can be merged into main branches or deployed.
The core goal is always to provide developers with actionable, context-rich insights quickly, helping them fix issues as they write the code, before the vulnerabilities propagate downstream and become much more expensive to remediate. SCA, on the other hand, software composition analysis, is specifically designed to sniff out known vulnerabilities and also license compliance issues within the open source components and third-party libraries that your application relies on. And this is incredibly important, as we said, raising that fundamental question about our growing reliance on external code and the inherent supply chain risks that come with it. Tools like SNCC, Mend, which used to be WhiteSource, Nexus Lifecycle, they maintain extensive databases of known vulnerabilities, CVEs. They scan your project's dependency files like maven pom.xml, npm package.json, python requirements.txt, and check if any included libraries have known issues. A powerful real-world example of SCA's impact. Imagine a build pipeline where an SCA tool flags a critical, newly disclosed vulnerability in a widely used logging library. If this were to happen, the tool could automatically prevent the build from completing, stopping that vulnerable component dead in its tracks, preventing it from ever reaching production. This proactive, automated measure can save an immense amount of time, resources, and potential reputational damage compared to discovering and patching it after deployment. It's huge.
Yeah, that is a direct, tangible way to prevent a major incident, a real security win right there. But code isn't the only thing that needs securing anymore, is it? Infrastructure is no longer just hardware racks, it's code. Infrastructure as code IAC, that's a massive paradigm shift. So how do we secure something that's constantly changing, constantly being deployed, and treated just like application code? The questions here really dig into this. How do you ensure secure configuration management for infrastructure as code IAC deployments? And can you share an example of how you've used infrastructure as code IAC scanning tools to improve security? And then zooming out a bit to the broader environment, how do you ensure secure configuration of cloud platforms like AWS, Azure, or GCP in a DevSecOps workflow?
You're absolutely right. The advent of infrastructure as code, using powerful tools like Terraform, CloudFormation, Ansible, Pulumi, it's truly revolutionized how infrastructure is provisioned and managed. It brings all those benefits we love in software development, version control, automation, reproducibility to infrastructure, which is great. However, it also means that misconfigurations or security vulnerabilities in that code can be replicated at massive scale, potentially leading to widespread and deeply ingrained security issues across your entire environment. So securing ISC deployments absolutely requires security checks before the infrastructure is actually provisioned or modified in the live environment. You have to catch it early. This translates to integrating ISC scanning tools directly into the CI/CD pipeline, but for the infrastructure code itself. These specialized tools, you might hear names like Bridgecrew, now Prisma Cloud, Checkoff, Terrascan, TFSec, even tools from the cloud providers themselves, they analyze your ISC templates. Your Terraform plans, your CloudFormation templates, your Kubernetes manifests, they look for insecure defaults, policy violations, unencrypted storage, overly permissive network rules, missing security controls, you name it. For instance, an IAC scanning tool could automatically detect if an S3 bucket is configured for public access, or if a security group allows all incoming traffic on a sensitive port like SSH port 22 or RDP port 3389. Big no-nos usually. If such misconfiguration is found, the deployment pipeline should ideally be blocked, and the developer responsible gets immediate actionable feedback right within their familiar workflow. And this approach also ties directly into securing the broader cloud platforms themselves. Cloud Security Posture Management, or CSPM, tools are designed to continuously monitor your entire cloud environments, be it AWS, Azure, or GCP. They ensure these environments adhere to defined security best practices and compliance benchmarks. Think CIS benchmarks, NIST guidelines, things like that. Many CSPM tools integrate seamlessly with IAC tools by providing policies that can be enforced right at the IAC creation stage. So you're not just securing the code that defines your infrastructure.
You're also continuously validating the running cloud environment against defined security baselines, flagging deviations in real time. These tools are absolutely vital for bridging that gap between development teams who might write the IAC and the operations or security teams who are ultimately responsible for the secure state and continuous compliance of the live infrastructure.
That sounds like a really powerful way to embed security into the very foundation of the environment, like true security by design, but for infrastructure. But beyond the static infrastructure, the rise of containers and serverless functions has completely changed application architecture, hasn't it? Moving us towards smaller, more agile units of deployment. How do we keep security in step with these rapid innovations? The questions here seem particularly relevant. How do you approach securing containerized workloads in a Kubernetes-based environment? And what is your experience with securing serverless architectures in a DevSecOps context? Also, maybe an example. Can you share an example of how you've used container orchestration tools to enforce security policies?
Yeah, these modern architectures, while offering incredible agility and scalability, definitely introduce a distinct set of unique security considerations. It's a different ballgame. For containerized workloads, Particularly in dynamic Kubernetes environments, security needs to be addressed comprehensively across multiple layers. It's not just one thing. First, container image scanning is paramount. Before any container image is pulled or deployed, it must be thoroughly scanned for known vulnerabilities. CVEs, embedded malware, maybe even accidentally exposed secrets or sensitive information in the layers. Tools like Claire, Trivy, Anchor, or scanners from cloud providers and vendors excel at this, integrating directly into image registries or CI/CD pipelines to act as gates. Block bad images early. Second, beyond the static image, runtime protection for containers is essential because things can change once they're running. This involves actively monitoring container behavior for suspicious activities and deviations from their normal expected operation. Solutions like Falco, Cystic Secure, Aqua Security, StackRock's Red Hat ACS, they can enforce granular policies at runtime. They can detect if a container tries to execute an unusual process, access sensitive files outside its scope, or initiate unauthorized network connections, basically watching for bad behavior. Third, network segmentation within Kubernetes is absolutely crucial. Implementing granular network policies allows you to restrict communication between microservices to only what's absolutely necessary. This rigorously enforces the principle of least privilege, but at the network layer. Don't let containers talk to each other if they don't need to. An excellent example of using orchestration tools for policy enforcement, as you asked, would be a Kubernetes admission controller. This is a powerful piece of code that intercepts requests to the Kubernetes API server before an object like a new deployment or pod is actually created or updated in the cluster. It can be configured to, say, block the deployment of unapproved container images, maybe ones that haven't been scanned, ensure all deployments have explicit resource limits defined, good for security and stability, or enforce specific security contexts that dictate permissions and user IDs within the container. These controllers automatically apply security policies based on the workload's identity or namespace, making policy enforcement built in rather than an easily forgotten afterthought. Now, for serverless architectures like AWS Lambda functions or Azure functions, the security model shifts quite dramatically again. You're securing individual, often ephemeral functions, not entire persistent servers or virtual machines. It's a different mindset. Key areas of focus here include ensuring stringent function-level permissions. The principle of least privilege is absolutely critical functions should only ever have the absolute minimum permissions they need to execute their specific task, no more. Securing the event triggers is also vital. For instance, ensuring S3 buckets triggering Lambda functions only allow specific authorized event types, or that API gateway endpoints are properly secured. Robust input validation for those API gateway endpoints that expose these functions is another essential layer, preventing common web application attacks from reaching your function code. Finally, comprehensive logging and monitoring for function execution, including unusual invocations, errors, duration anomalies, becomes the primary means of detection and investigation. The ephemeral nature of serverless means that traditional host-based security tools are largely irrelevant, and the focus shifts almost entirely to identity and access management, IAM, API security, configuration, and securing the data flows between functions and other cloud services.
Okay, beyond the foundational elements of code and infrastructure security, there are other critical areas where security can truly make or break a system, right? Let's delve into some of those often overlooked but absolutely vital aspects, starting with one of the most basic, yet potentially most devastatingly simple, attack vectors as secrets. Things like passwords, API keys.
Oh, absolutely. You've highlighted a critical vulnerability that persists in far too many environments even today. Managing secrets correctly isn't just a nice-to-have best practice. It's foundational to preventing pervasive compromise. Hard-coding sensitive information like API keys, database credentials, or private certificates directly into code or configuration files or even environment variables is just a monumental risk. If that code or configuration is ever exposed even accidentally through a public code repository or a misconfigured log file, those secrets are instantly compromised, basically granting attackers the keys to your kingdom. This brings us to a crucial question from our sources. How do you ensure secrets management, example, API keys credentials, in a Devsecops pipeline? And, equally important, recognizing their increasing prevalence and importance, how do you ensure secure API development and management in a Devsecops workflow?
Yeah, when I think about the modern web, it often feels like it's just APIs talking to other APIs behind the scenes. Everything connects through them. And that realization makes me wonder, with so many of these digital conversations happening constantly, how do we ensure the security of those critical communication points? It feels like an incredibly broad yet vital attack surface, doesn't it?
It absolutely is the new, or at least a primary frontier of attack surfaces, no question. For secrets management, the robust solution lies in using dedicated secrets management solutions. Think HashiCorp Vault, AWS Secrets Manager, Azure Key Vault, Google Cloud Secret Manager, Doppler, tools like that. These platforms are purpose-built to securely store, access, and manage secrets throughout their entire lifecycle, from creation to rotation and eventual revocation. In a modern DevSecOps pipeline, the practice is to never hard-code secrets. Never, ever. Instead, applications and services are designed to fetch the necessary credentials from the secrets manager at runtime, just before deployment perhaps, or during application startup. Even more advanced, many of these systems support dynamic secrets. This is really cool. Credentials are created on the fly, they have a very short lifespan, maybe minutes or hours, and they're automatically expired and rotated after use. This dramatically shrinks the window of opportunity for an attacker to compromise a static secret, because the secret simply doesn't exist for long periods. The principle of least privilege is also vital here. Ensure that only the necessary applications or services have access to specific secrets, and only when they absolutely need them for their authorized operations. Fine-grained control. Imagine a scenario where a DevSecOps pipeline automatically injects temporary rotated credentials into a deployment. It completely eliminates the risk of static keys being compromised, even if the deployment package itself somehow falls into the wrong hands. It's a real game changer for credential security. As for API security, given their ubiquitous use across microservices, mobile apps, third-party integrations, you name it, they are indeed a primary and incredibly lucrative attack surface for adversaries. They're going after APIs hard. Secure API development and management must encompass several critical layers. First, strong, potentially multi-factor authentication and granular authorization mechanisms are critical, ensuring only legitimate users and services can access APIs, and only with the precise permissions they require. This often involves robust standards like OAuth 2.0 and OpenID Connect, coupled with fine-grained access control lists or policy engines. Second, absolutely robust input validation on all API endpoints is essential to prevent a wide array of injection attacks. SQNI, cross-site scripting, XSS, XML, external entities, XXE, command injection, all that nasty stuff. Validate everything coming in. Third, implementing rate limiting and throttling, usually at the API gateway level, helps prevent denial of service, DOS stacks, or brute force attempts against credentials or resources. Fourth, API gateways themselves play a pivotal role. They act as a single enforcement point for security policies, routing, sometimes even basic threat detection and attack blocking before requests hit your backend services. Finally, continuous real-time monitoring of API traffic for anomalous behavior, strange request patterns, error spikes, unexpected data sizes is key to detecting and responding to attacks as they happen.
We're certainly not building everything from scratch anymore, are we? Modern software feels like this vast tapestry woven from countless external components and services. That makes me, frankly, deeply concerned about the integrity of everything we use. How do we trust our supply chain? It feels fragile sometimes. This brings us to the crucial questions around dependency management and third-party integrations. How do you handle dependency management to prevent supply chain attacks in a DevSecOps environment? And how do you approach securing third-party integrations in a DevSecOps workflow? And maybe even more broadly, what steps do you take to ensure secure software supply chain practices in a DevSecOps environment?
This is arguably one of the most critical and rapidly evolving areas in cybersecurity today. You're right to be concerned. High-profile incidents like SolarWinds, Kaseya, Log4j, they was stark, painful reminders of just how devastating a supply chain compromise can be. It's terrifying stuff. It's no longer just about securing your own meticulously crafted code. It's about securing everything that goes into it and everything it connects to. The attack surface has just exploded exponentially. For dependency management, as we briefly discussed with SEA tools earlier, rigorously vetting third-party components is absolutely fundamental. But it goes beyond just scanning. It means not just scanning for known vulnerabilities, CVEs, but also trying to understand the provenance of the component. Where does it come from? Who maintains it? Does it have an active community? Is there a historical track record of security issues or neglect? Maintaining a software bill of materials, or SBOM, is becoming increasingly important. It's moving rapidly from a niche practice to a mainstream necessity, even a requirement in some sectors. An SBOM is essentially a complete, often machine-readable inventory of all the open source and third-party components used in a software product. It allows you to quickly identify your exposure if a new vulnerability is discovered in one of those components down the line, or if a specific license requirement changes. You need to know what's inside your software. Beyond just the components, securing the broader software supply chain involves critically important practices like signing artifacts. This uses digital signatures, like GPG or SigStore, to cryptographically ensure that the software binaries, Container images or other deployment artifacts you're using haven't been tampered with or modified since they were legitimately built and approved. Verifiable integrity. Implementing strict access controls for your build systems and CI/CD platforms themselves is also crucial, as these are prime targets for sophisticated attackers looking to inject malicious code right into the heart of your software factory. Protect the build pipeline itself, and regularly auditing all third-party services and integrations from your SaaS providers to cloud services to any external APIs you consume is another non-negotiable step. You need to ensure they meet your security requirements and adhere to your risk appetite. It's about managing third-party risk continuously.
That emerging landscape of software provenance and attestation, especially in the face of increasingly sophisticated supply chain threats, sounds incredibly complex, almost overwhelming. How will organizations keep up with this arms race? It seems like a constant uphill battle.
You're right, it is a continuous arms race, but the trend is very much towards greater transparency, automation, and verifiable trust. We have to move in that direction. Initiatives like SLSA, that's supply chain levels for software artifacts, are emerging as frameworks that provide a standardized way to ensure the integrity and security of the software supply chain. Think different levels of assurance. This involves creating verifiable metadata about how software was built, by whom, and with what dependencies throughout its entire lifecycle. Provenance matters. We'll see attestation services become more common, providing cryptographic proof of various stages of the build process. Think SigStore again. The future will likely involve more widespread adoption of technologies like maybe distributed ledgers or verifiable credentials to provide immutable, irrefutable evidence of software origin and integrity, right from the source code commit to the final deployment artifact. It's really about building trust not through blind faith in a package name, but through cryptographic proofs and transparent automated processes that we can verify.
Okay, it's one thing to talk about implementing security, about shifting left and integrating all these tools. That's great. But how do we actually know if it's working? How do we measure the impact of all this effort? Is it making a difference? And crucially, what happens when, inevitably, things go wrong anyway? How do we respond? This moves us squarely into the realm of metrics, compliance, and swift incident response, doesn't it?
Indeed, Devsecops isn't just about implementing security mechanisms. It's fundamentally about making security measurable, continuously improving it, and fostering resilience when things do break. Many organizations, as you know, operate within highly regulated industries, which immediately brings up the question, how do you balance the need for rapid deployments with compliance requirements in regulated industries? That's a constant balancing act. And more broadly, what metrics do you track to measure the effectiveness of a DevSecOps program? Not just activity, but effectiveness. Along with, how do you ensure compliance with standards like GDPR, EP, or PCI DSS in a DevSecOps pipeline?
It often feels like security can sometimes be perceived as a bottleneck, a brake on speed. But you're implying it can actually enable faster, safer delivery if done right. That's a powerful idea if achievable.
It absolutely can, and arguably should. DevSecOps, done right, is not about slowing down. It's about making security an enabler of both speed and robust compliance. They aren't mutually exclusive. The concept of compliance as code is vital here. This means automating checks for regulatory adherence directly within the pipeline itself. Instead of relying on manual, periodic, often painful audits long after the fact, you have automated tools that continuously verify configurations, access controls, data handling practices, encryption settings, all against predefined regulatory requirements. For example, if a PCI DSS control requires specific data encryption for cardholder data, your IAC scan might automatically check for it before deployment, or your CI/CD pipeline might enforce that only encrypted connections are used for services handling that data. This provides continuous assurance and immediate feedback, allowing you to catch and correct compliance deviations as they occur, rather than discovering them months later during a stressful audit. As for metrics, it's absolutely crucial to track those that demonstrate tangible effectiveness and impact, not just activity or the sheer number of scans run.
Volume doesn't equal value. Key metrics include mean time to detect, or MTTD, and mean time to respond, or MTTR, for security incidents. How fast do we find things? How fast do we fix them? A decreasing MTTD means you're finding issues faster. A decreasing MTTR means you're fixing them faster and more efficiently. Those are good trends. Other vital metrics are things like vulnerability density. How many vulnerabilities per lines of code, per application, or per deployment over time? The percentage of automated security tests integrated into your pipeline, are you automating enough? Security findings per sprint, are you addressing them? And most critically, the measurable reduction in critical vulnerabilities found in production over time. That's the bottom line. This raises a fundamental question, doesn't it? Are we merely measuring the activity of security teams like we ran 1,000 scans, or are we measuring the actual impact on our security posture and overall risk reduction? We reduced critical production vulns by 30%. A mature Devsecops program should show a clear, measurable, and tangible improvement in the security health of your applications and infrastructure.
Imagine a dashboard showing the decreasing trend in critical vulns found in production, directly correlated with increased SASTAN and DAS coverage in CI/CD. That clearly demonstrates the positive impact on the bottom line, reduced risk and cost.
Monitoring sounds straightforward enough on the surface, but in a dynamic DevSecOps environment with constant changes, ephemeral containers, serverless functions popping up and disappearing, it feels like a persistent, often overwhelming challenge, just keeping track of everything. And when an incident does hit, how do we react swiftly and effectively to minimize the damage and restore service? This brings us to questions like, how do you approach continuous monitoring for security in a DevSecOps pipeline? And how do you approach incident response and recovery in a DevSecOps pipeline? Plus, maybe a specific example. Describe a scenario where you improve the mean time to detect MTTD, or mean time to respond, MTTR for security incidents. And finally, can you share an example of how you've used logging and monitoring to improve security in a DevSecOps pipeline?
You're right. Continuous monitoring truly is the eyes and ears of your security program. It provides the necessary telemetry to understand your security posture at any given moment. But it needs to be smart. It starts with implementing robust, standardized logging across all applications, infrastructure components, cloud services, and security tools. Everything needs to log, and log well. These logs must then be centralized into a security information and event management, or SUM system, or perhaps a dedicated centralized logging platform like Splunk, Elasticstack, Datadog, etc. Centralization is absolutely key. It allows for the correlation of events across the entire environment, revealing attack chains or patterns that looking at individual logs in isolation might completely miss. Proactive alerting is the next critical step. Defining intelligent thresholds and rules that automatically trigger alerts for suspicious activities, an unusual number of failed logins, policy violations detected by CSPM, anomalous network traffic patterns identified by network sensors. Monitoring isn't merely about collecting vast amounts of data drowning in logs. It's about deriving actionable intelligence from it, ideally in near real time. Now, when an incident hits, the DevSecOps approach to incident response is fundamentally different from traditional siloed approaches. It's highly integrated, collaborative, and wherever possible, automated. It's about moving from a reactive, often isolated security team response to an integrated, collaborative process that involves developers, operations, and security working together. This means embedding incident response playbooks directly into the operational workflows and potentially even the CI/CD pipeline itself. For example, if a critical vulnerability or a live exploit is detected in production, automated scripts, maybe via SO, which we'll touch on, might immediately trigger initial containment actions like isolating affected services using network policies, temporarily blocking malicious IP addresses at the firewall or CDN, or initiating a forced password reset for potentially compromised accounts. Simultaneously, these actions trigger immediate alerts to the relevant development and operations teams through their preferred communication channels, Slack, Teams, PagerDuty, whatever they use. Get the right people involved fast. Postmortems are absolutely crucial for continuous improvement. After every significant incident, conduct a blameless postmortem to deeply understand the root causes, identify any gaps in the pipeline, monitoring or response processes, and crucially, integrate those learnings back into the CI/CD pipeline for future prevention. Fix the process, not just the bug. Incident playbooks shouldn't be static documents gathering dust. They are living artifacts, regularly tested and refined, often through things like chaos engineering exercises or security drills that simulate attacks to test resilience in a controlled environment. As for a concrete example of improving MTTD/MTTR using logging, consider an organization struggling with slow detection of compromised user accounts because logs were scattered everywhere. Very common problem. By implementing centralized logging across all their applications and cloud services, feeding this into a modern SIEM, they gain that crucial holistic view. They then leverage the SIEM's correlation capabilities to automatically link, say, a high number of failed login attempts from unusual geographic locations with subsequent successful logins from those same suspicious regions for the same user account. That's a strong indicator. This correlation could instantly flag a high-confidence compromised account, dramatically reducing MTTD from potentially hours or days down to mere minutes. Huge improvement. To improve MTTR, they could then automate the response. If an account was flagged with high confidence by that SIEM rule, it could automatically trigger a workflow, maybe via SOAR, to force a password reset for the user, temporarily suspend the account, and notify the Security Operations Center. This leads to an immediate reduction in the time it took to contain the threat and restore normal operations, preventing further lateral movement by an attacker. That's a direct, impactful application of logging, monitoring, and automation working together.
That's a powerful transformation, going from slow and manual to fast and automated. And as we look to the future, how do emerging technologies like AI and machine learning enhance this? How do they help with continuous monitoring and accelerate incident response? It feels like they're almost tailor-made for this kind of complex problem.
You're absolutely right. AI and machine learning are revolutionizing this space. They're moving us beyond the limitations of static, rule-based alerting, which, let's be honest, often leads to overwhelming false positives and terrible alert fatigue for security teams. ML algorithms can ingest and analyze truly vast data sets of logs, network traffic, endpoint telemetry, user behavior, you name it. They can identify subtle anomalies and complex patterns that indicate sophisticated threats, things that human analysts sifting through millions of events might easily miss. They can establish dynamic baselines of normal behavior for users, systems, and network traffic, and then flag deviations that might represent emerging threats. This significantly helps reduce false positives and allows teams to prioritize the truly critical alerts. For incident response, AI can act as an incredibly intelligent assistant. It can help correlate events across multiple disparate systems much faster, provide crucial context around alerts, and even suggest severity assessments based on learned patterns, often faster than human analysts can piece it all together. It can also recommend containment and remediation steps based on analysis of past incidents and known threat patterns, thereby significantly accelerating MTTR. We're seeing a strong trend toward things like extended detection and response, or XDR, platforms. These leverage AI to unify and analyze data from endpoints, networks, cloud infrastructure, identity systems, email, etc., to provide a truly holistic and intelligent view for threat detection and rapid response. It's really about augmenting human capability, freeing up analysts to focus on the complex investigations, not replacing them entirely.
Devsecops is so often described, perhaps even primarily, as a cultural shift as much as, or maybe even more than, a technical one. We can deploy all the fancy tools in the world, but if the human element isn't aligned, if the culture isn't right, it feels like it won't truly stick, will it? How do teams genuinely work together across those traditional silos, dev, secit, ops? And how do you champion security when deadlines are looming large and the pressure to just deliver something is intense? This is where the human element really comes into play.
It really does. And what this truly highlights, I think, is that effective DevSecOps is fundamentally built on breaking down those deeply ingrained silos. We have to stop pointing fingers. It's about cultivating shared responsibility, mutual understanding, and genuine empathy between development, security, and operations teams. They need to be partners, not adversaries. This cultural aspect is absolutely crucial when addressing those persistent, thorny questions like, how do you prioritize security tasks in a fast-paced DevOps environment without slowing down delivery? It's the million-dollar question, isn't it? And how have you handled a situation where a security fix conflicted with a tight release deadline? Everyone's faced that one. Also, the very fundamental, how do you ensure collaboration between development, security, and operations teams in a DevSecOps culture? How do you make it real? And the perennial, often unspoken conflict. How do you handle conflicts between security requirements and developer productivity in a DevSecOps team?
Yeah, those last two questions really get right at the heart of the daily friction points, don't they? The moments where the rubber meets the road. It's easy to say collaborate, but it can be really hard to do when priorities seem to diverge so sharply.
You're absolutely right. That's precisely where theory meets the messy reality of deadlines and different objectives. Prioritization in a fast-paced environment inherently requires a robust, risk-based approach. As we've said, not all security findings are created equal, not by a long shot. Critical vulnerabilities, those that are easily exploitable and have a high potential business impact, think data breaches, severe financial losses, major reputational damage, should always take immediate precedence. That has to be clear. This demands close alignment with overarching business goals. What assets are most critical to the business? What data is most sensitive and regulated? Security priorities need to reflect business priorities. Embedding security tasks directly into agile sprints alongside new features and bug fixes with a transparent, dedicated allocation of sprint capacity helps ensure they aren't perpetually pushed to the next sprint in favor of new functionality. Make security work visible and planned. It's about making security a first-class citizen in the product backlog, not an afterthought. Handling conflicts with tight release deadlines is never simple and requires open, honest communication and transparent risk assessment. Crucially, without judgment or blame. It'd have to be a collaborative conversation. not a top-down mandate from security saying, "Thou shalt not release." The security team needs to clearly articulate the business risk associated with a known vulnerability. What's the likelihood of exploitation? What's the potential impact of financial, reputational, legal, operational? Frame it in business terms. Can a temporary mitigating control be put in place to reduce the immediate risk and buy time for a proper fix later? Is that acceptable risk? Sometimes, the difficult but correct decision is to delay a release for a critical vulnerability. But this decision should ideally be made collaboratively, with senior management actively supporting security as a fundamental business enabler, not just a reactive cost center or the Department of No. Their backing is vital. It's about building a deep level of trust so that developers genuinely see Celerity as a partner, an enabler of quality and reliability, rather than an impediment or just a team that always finds problems.
A powerful example of effective collaboration. Think of a DevSecOps team using shared communication channels like dedicated Slack or Teams channels and regularly holding joint backlog grooming sessions where security findings are discussed right alongside feature requests and bugs. That transparency ensures everyone understands the trade-offs, participates in finding solutions, and shares ownership of the overall security posture.
It sounds like it's not enough just to know the tech. Sometimes you truly have to be a teacher, a coach, maybe even a diplomat sometimes. How do you bring everyone along on this journey, especially when there's that inherent tension between speed and caution, features and security? The questions here seem incredibly relevant. Describe a time when you had to educate a development team on DevSecOps best practices. How did you approach it? And maybe looking upwards or outwards, describe a time when you had to advocate for DevSecOps practice to stakeholders. How did you make your case?
Education and advocacy are truly cornerstones of any successful DevSecOps adoption. Absolutely critical. When educating a development team, traditional lecture-style presentations or just sending links to lengthy documentation often fall flat in a fast-paced environment. People just don't have time or attention for that. A far more effective approach is to embrace adult learning principles. Focus on practical, hands-on workshops where developers can directly apply secure coding principles, often using their own code bases as examples. Make it relevant to their work. Gamified training platforms, internal capture the flag, exercises focused on secure coding, or informal brown bag lunch and learn sessions are fantastic ways to make learning engaging and directly relevant. Keep it interesting. The key is to provide actionable, constructive feedback rather than just issuing mandates or pointing out flaws. Instead of simply stating your code is insecure, show them why it's insecure, how an attacker might exploit it, and most importantly, how to fix it, perhaps with concrete code examples and refactoring patterns they can use immediately. Emphasize that secure code is inherently better code. It's more resilient, more reliable, generates fewer costly production bugs, and ultimately accelerates long-term delivery by reducing rework and incidents. Secure code is quality code. For advocating to stakeholders, whether they are product owners, senior management, or even finance teams, the language absolutely needs to shift from technical jargon to quantifiable business impact. You have to speak their language. You need to translate technical risks into clear financial implications, potential fines from regulatory bodies like GDPR, lost revenue from downtime due to a breach, the immense cost of incident response and recovery, legal fees, forensics, PR, and the long-term erosion of customer trust and brand reputation, which can be devastating. Presenting a clear return on investment, or ROI, for security investments is critical, even if it's sometimes hard to quantify perfectly. For example, instead of saying we need to invest $6 in a SaaS tool because it catches injection flaws, you might frame it as, by investing $6 in automated SaaS early in the pipeline, we project a reduction in the cost of fixing vulnerabilities later by, say, 10x, potentially saving the company dollars annually in remediation costs and significantly reducing our risk of data breaches, which could cost COZ by W%. This directly impacts our customer trust, competitive advantage, and regulatory compliance, ultimately allowing us to innovate faster with less risk. Use compelling data, relatable anecdotes like recent breaches of competitors, and clear metrics tied to business outcomes to make your case. Show how security actively enables business growth and systematically reduces overall organizational risk.
Right. It's clear that it's not just about ticking compliance boxes, but about strategic business advantage and risk management. How, then, can organizations foster a truly security-first mindset organically, from the ground up, rather than just through top-down enforcement that can sometimes breed resentment or just passive compliance?
Building an organic security-first mindset, that's the holy grail, isn't it? It requires embedding security into the daily rituals, the incentives, and the very culture of development and operations. It definitely begins with visible, unwavering leadership championship for security. Leaders need to provide the necessary resources, time, and demonstrate consistently that security is a shared value, not just a department's problem or a cost center. Tone from the top matters hugely. It involves democratizing security knowledge, making it effortlessly easy for developers to find answers to security questions, access secure coding libraries or patterns, and use intuitive security tools that don't get in their way. Remove the friction. Gamification, as we touched on, can be incredibly powerful here. Think of internal bug bounty programs for your own code bases, rewarding developers for finding and fixing vulns, or even security hackathons where development teams compete to find and fix vulnerabilities in a fun, challenging way. Make it rewarding. Another highly effective approach is to have security teams act as embedded consultants or partners, actually sitting with development teams, pairing on secure coding practices, offering guidance in real time during design sessions, rather than being an external auditing body that only appears at the end to say no. Be a helper, not just a gatekeeper. When developers feel empowered, supported, equipped, and genuinely recognized for their direct contributions to security, the mindset shifts fundamentally from obligation or fear towards deep ownership. Security becomes a natural and cherished part of their craftsmanship, part of building great software.
Okay, finally, let's zoom out just a bit. DevSecOps isn't a static destination, clearly. It's a dynamic, constantly evolving journey. The threat landscape shifts daily, new technologies emerge, architectural patterns change at a dizzying pace. It's hard to keep up. What are some of the strategic approaches and bigger picture concepts guiding its future? Where is this all heading?
The landscape is indeed extraordinarily dynamic, constantly shaped by new architectural patterns like microservices and serverless, emerging technologies like AML and eBPF, and of course an ever-evolving, increasingly sophisticated threat landscape. We can't stand still. Two critical strategic approaches immediately come to mind that illustrate this dynamism, and they're reflected in our source questions. Describe your approach to conducting threat modeling in a DevSecOps context, and how do you approach securing microservices architectures in a DevSecOps environment? Threat modeling, as we briefly touched upon earlier, is that proactive design activity to identify potential threats and vulnerabilities early in the software development lifecycle. Find problems before you build them. In a modern DevSecOps context, this isn't a one-off heavyweight academic exercise done only at the start of a massive project. That doesn't scale in agile environments. It should be deeply integrated into agile sprints and done iteratively, becoming a natural part of every planning cycle. Maybe even for individual user stories or features. Keep it lightweight and continuous. Teams might use structured methodologies like STRIDE, spoofing, tampering, repudiation, information disclosure, denial of service, elevation of privilege, to systematically categorize potential threats, or DREAD, damage, reproducibility, exploitability, affected users' discoverability, to help quantify and prioritize risks. Or simpler methods like just asking what could go wrong. The ultimate goal is to make threat modeling a collaborative exercise, a shared language and activity between architects, developers, testers, product owners, and security specialists. It embeds security considerations from the very moment a new feature is conceptualized. For instance, before developing a new API endpoint, the team might conduct a quick, focused threat model, maybe just 15-30 minutes, to identify potential injection points, authorization bypasses, or data leakage risks specific to that API, ensuring those are addressed directly in the API design itself, long before any code is written or caught by a later scan. Now, securing microservices architectures is fundamentally different and often far more complex than securing traditional monolithic applications. It presents unique challenges. What's fascinating here is how those fundamental architectural choices, breaking things down into tiny pieces, profoundly impact the security complexity and the strategy you need to employ. With microservices, you inherently have a significantly increased attack surface. Why? Because there are many more discrete services, many more network endpoints to secure, and significantly more inter-service communication paths that could potentially be intercepted or manipulated. More moving parts equals more places to attack. The security approach includes ensuring robust, secure inter-service communication, for example, using mutual TLS, MTLS, authentication between services, maybe via a service mesh like Istio or Linkerd, securing the API gateways at the ingress points, implementing decentralized identity management for services themselves, allowing services to authenticate and authorize each other securely, perhaps using SPIFFire, and applying the principle of least privilege rigorously to each individual service's permissions and network access. Network segmentation using Kubernetes network policies or service mesh policies, as discussed earlier, and robust API security for all external and internal APIs become even more critically important when managing security across potentially hundreds or thousands of small independent services. Each microservice essentially becomes its own security boundary, requiring its own set of policies and controls, which demands a high degree of automation and policy as code.
You mentioned zero trust principles earlier. That sounds like quite a radical idea. Never trust, always verify, assume breach no matter what or where. How does that translate practically to our pipelines and our systems, especially in such a dynamic, automated environment? This is explored in the question, what is your experience with implementing zero trust principles in a DevSecOps pipeline? And thinking about how we actually glue all these disparate security controls and tools together into something coherent, can you describe your experience with security orchestration and automation tools in a DevSecOps context? That's for our tools, right?
Zero trust is indeed a fundamental paradigm shift, yes. It's moving away decisively from that old perimeter-based security model, the flawed idea that once you're inside the network, you're somehow inherently safe and trusted. Zero trust assumes threats exist both outside and inside the network. It's founded on three core tenets, generally: explicit verification, never trust, always verify every access request, granting least privilege access, give only the minimum necessary permissions, and assuming breach, which drives pervasive microsegmentation, breaking networks and applications into small, isolated zones to limit blast radius. In a DevSecOps pipeline, this translates to rigorously securing every single component and interaction of the pipeline itself. It's not just about securing the output of the pipeline, but the pipeline's integrity too. For example, implementing zero trust means limiting permissions for CI/CD jobs or runners to only the exact cloud resources, repositories, or secrets they need for only the exact time they need them, and ideally verifying their identity cryptographically before granting access. Every interaction, every data transfer between pipeline stages, every user access to the pipeline tools should be authenticated and authorized based on identity and context, regardless of whether it's considered internal. An excellent illustrative example might be a developer's access to production infrastructure being granted just in time, JIT, for a specific troubleshooting task, perhaps via a tool that brokers access, and then automatically revoked after that task is completed or after a very short time window. That fully embodies the never trust, always verify, and least privilege principles. Security orchestration and automation, often abbreviated as S4, tools are truly the connective tissue, you could say. They're the glue that brings together disparate security tools and automates complex, often repetitive, security workflows. They allow you to define sophisticated security playbooks, essentially, codified incident response or vulnerability management processes that can automatically trigger actions based on alerts from your monitoring systems, like your SIEM, your individual security tools, like endpoint detection or cloud security tools, or even threat intelligence feeds. This could be anything from automatically blocking a malicious IP address detected by your web application firewall across all firewalls, enriching a security alert with context from VirusTotal or other threat intel feeds, automatically quarantining a suspicious endpoint using your EDR tool, or even creating a detailed GIRA ticket for a developer with all the necessary information to fix a newly discovered vulnerability flagged by your SaaS tool. SOAR, platforms like Splunk SOAR Phantom, Palo Alto Networks Cortex X SOAR, Microsoft Sentinel SOAR capabilities, Swimlane, Tines integrate with your existing security tools, your ticketing systems, and your communication platforms, Slack, email, to streamline incident response, vulnerability management, and even some compliance checks. They significantly reduce manual effort, help eliminate human error in repetitive tasks, and dramatically improve response times, MTTR, allowing security teams to focus their precious time on the more strategic, complex threats and investigations rather than just chasing low-level alerts all day. They're a huge force multiplier.
That makes sense. But, so many organizations weren't born in the cloud or with microservices from day one. Many are still grappling with large, complex, monolithic legacy systems. What about those older systems? Can DevSecOps even apply there? And how do we choose the right tools from the seemingly overwhelming number of options out there in the market today? It's dizzying. We have questions like, what challenges have you faced when implementing DevSecOps in legacy systems, and how did you overcome them? And how do you evaluate and select DevSecOps tools for a specific project or organization?
Legacy systems. Yes, implementing DevSecOps principles and tooling in legacy environments presents true, unique, and often formidable challenges, no doubt about it. These systems frequently lack automation capabilities built in. They're often built on monolithic architectures that are hard to test or change incrementally, and they might use older programming languages or frameworks that don't easily integrate with modern SaaS, DAST, or SCA tooling. The ecosystem just isn't there sometimes. Overcoming these challenges almost always requires a phased, pragmatic approach rather than a disruptive Big Bang overhaul, which is often impossible or too risky. You have to be realistic. Strategies often include using wrapper scripts to automate manual steps around the legacy system, like triggering scans or deployments, implementing API gateways in front of monolithic applications to enforce modern security controls like authentication, rate limiting, and input validation without rewriting the entire backend, or even strategically breaking down specific high-risk parts of the legacy system into microservices over time to modernize them incrementally, the Strangler fig pattern. Prioritizing the highest risk components of the legacy system for applying security testing, monitoring, or implementing additional compensating controls around them is also key. You can't boil the ocean. Focus on where the biggest risks lie. It's definitely a journey of gradual, continuous improvement and risk reduction, rather than a single, rapid transformation like you might attempt with a greenfield application. When it comes to evaluating and selecting Devsecops tools, yeah, the market is indeed saturated and can be incredibly overwhelming. It's crucial to look far beyond just the flashy feature list on the vendor's website. A tool's real effectiveness is often determined by how well it fits into your unique ecosystem, your workflows, and your organizational culture. Key considerations absolutely must include: 1. Integration capabilities. How seamlessly does the tool integrate with your existing CI/CD pipeline, Jenkins, GitLab CI, GitHub Actions, Azure DevOps, your source code management system, Git, your ticketing systems like Jira, and importantly, other security tools you already use. A tool that creates friction or requires manual data shuffling will inevitably lead to abandonment or inefficiency. 2. Ease of use for developers. This is huge. If the tool generates an excessive number of false positives, noise, requires complex configurations just to get started, or produces reports that are difficult for developers to understand and act upon, they will quickly become fatigued and disengage. It must provide actionable, context-rich feedback that genuinely helps them fix issues efficiently within their existing workflow. 3. Accuracy and precision. You need to strive for a good balance between false positives, legitimate code incorrectly flagged as vulnerable, and false negatives, missed vulnerabilities. Overly noisy tools lead to alert fatigue and distrust, while tools that consistently miss critical issues are fundamentally useless, even dangerous. Look for tuning capabilities. 4. Scalability. Can the tool handle the volume and complexity of your code, your infrastructure definitions, and your deployment frequency, not just today, but as your organization grows and your projects expand? Will it choke under load? 5. Total cost of ownership, TCO. Look beyond just the licensing fees. Consider the operational overhead. How many people to run it? The necessary training requirements for your teams, the ongoing maintenance and tuning effort, and the compute storage resources needed to manage and run the tool effectively. What's the real cost? The best approach often involves running proofs of concept, POCs, or pilots with a few top contenders, gathering direct, unfiltered feedback from the developers and security engineers who will actually use the tools day to day, and rigorously assessing their real-world impact on your security posture and your development velocity. Don't just buy based on a demo. Test and validate in your environment. Hashtag outro.
So what does this all really mean for you, our listener? We've just taken a pretty deep dive into the very questions that truly define practical expertise in DevSecOps. From the critical importance of integrating security into every single step of the CI/CD pipeline, to the profound impact of shifting security left by involving developers right from day one, to understanding the myriad of powerful tools that make this possible, and perhaps most crucially, to fostering that pervasive culture of shared responsibility and continuous learning. It's a lot to take in.
Yeah, and what this truly illuminates, I hope, is that mastering the implications behind these questions equips you not just with theoretical knowledge, but with a robust, actionable framework for navigating the complex and constantly evolving world of modern software security. These aren't simply interview questions to memorize and recite. They are a living roadmap for designing, building, deploying, and maintaining resilient, secure systems in today's incredibly fast-paced digital environment. They represent real challenges and real solutions.
You've gained a powerful shortcut today, hopefully, a distilled understanding of a truly complex domain. So think about this as you go. If you were tasked with designing the ultimate secure software delivery pipeline from scratch, maybe for your own organization, armed with all the insights from these deep questions, what would be the single most disruptive yet most effective change you would champion first? Where would you focus your energy to create the biggest security impact with the least amount of friction? Something to ponder.
That raises an important, ongoing question for all of us in this dynamic field, doesn't it? In a world where software is constantly evolving and new threats emerge literally daily, how do we ensure that our learning in DevSecOps is as continuous, as integrated, and as agile as the very practices we aim to implement? The questions, well, they never really stop, and neither should our pursuit of better, more effective answers. Keep learning.
Absolutely. Well, thank you for joining us on this deep dive into the core questions that really unlock DevSecOps. We sincerely hope this conversation has given you a fresh perspective and armed you with some incredibly valuable insights you can take back and use. Keep learning, keep questioning, and we'll catch you on the next deep dive.